Hi everyone and welcome back to our YouTube channel Code and Create. I'm so glad to have you here for the next part of our series. In the last part, we worked on building and animating the review section, creating a dynamic carousel that showcased client testimonials with smooth transitions and interactive elements. Today we're moving forward to build an exciting new section, the project section. In this part, we're going to showcase our portfolio of work. We will add filter buttons to categorize the projects based on the technologies used, and we will introduce animations to make this section more engaging and interactive. Our goal is to create an impressive display of projects that not only looks visually appealing but also provides an intuitive user experience. Before we dive in, please take a moment to like this video, subscribe to the channel, and hit that notification bell so you don't miss out on future tutorials. And of course, leave a comment if you have any questions or thoughts. Your support really helps keep this content going, and we love hearing from you all. Now let's take a detailed look at what we are about to build. In the project section, we'll be adding a beautiful set of animated project cards. Each card will contain an image, title, and description of the project, which will reveal more details when you click on it. We will implement a filter system using buttons that will allow us to display projects based on their category. The filter buttons will have smooth animations, scaling up when selected and dimming when not. This not only makes the interaction feel responsive, but also provides clear visual feedback on the active filter. We will also add dynamic animations to the project cards. When you first scroll to the project section, each card will slide into view with a smooth spring-like motion. The cards will cascade in from different directions depending on their position in the list, creating a lively, flowing effect that catches the user's eye. We will even animate the overlay that appears when you click on a project, making it gracefully fade in to showcase more information. This subtle opacity transition will make the experience feel seamless and polished. By adding these animations, we will turn a static grid of projects into an interactive showcase that's not only visually stunning but also user-friendly. So let's get started. The first thing that we have to do is to create a new component in the components folder. I'm going to call the new component projects. Then inside this file, I'm going to create a new functional component using RAFCE shortcut. Then instead of this line of code, I'm going to insert use client. Then we have to open page.js file and we have to import newly created component. Let's change the name. We need here projects. And also I'm going to nest this newly created component here. We need projects. All right, let's go back to the projects.jsx file and I'm going to create here the content of the component. So I'm going to get rid of this text from here and then I'm going to insert heading, which we have used for several times in the previous parts. I'm going to specify text and it's going to be projects. Then we have to import this component here because as you can see we got an error here. So let's import heading from sub and then I have to select heading. Now if we go to the browser, we will find here projects. All right, after that I'm going to add some more content here. After heading, I'm going to open div tag. Then inside the div tag, we need button. And as the content, I'm going to insert here all. Then after this div element, I'm going to open another div. And I'm going to insert here project. So now we're going to create a new subcomponent for individual project. Let's go to the subcomponent and create new file. It's going to be projects.jsx. Then we have to create a new functional component using RAFCE. Then let's add here use client. After that, I'm going to import this file here, So we need projects from, again, sub folder, and then we need to select projects. And now, instead of this hard-coded text, I'm going to nest the newly imported component. We need projects. Now, if we go to the browser, you'll find here the button all and also the project, which is imported from the newly created subcomponent. All right. Now I'm going to start to style those elements. Let's start with the first development, which is the wrapper of the content. So let's add class name. I'm going to define minimum height, which is going to be screen. I mean 100 viewport height. Then I'm going to define padding vertically. So we need py equal to 20. And then we need horizontal padding, px equal to 80. So as you can see, the space on the left and right sides, also at the top and bottom, is created. After that, I'm going to customize div, which is placed after heading. So let's add here class name. I'm going to use flex layout, therefore we need here flex. Then I'm going to use flex wrap in order to place flex items on different lines. Next, I'm going to use item center to place the flex items vertically in the center. And then let's use justify between in order to create some space between the flex items. I mean horizontally. Now I'm going to create some gap on all four sides using gap 4. And finally, let's create padding vertically using py with the value 10. After that, let's customize the button. I'm going to add here class name. We need border. Then I'm going to define the color of the border. We need border yellow 500. After that, I'm going to make the button rounded using a rounded XL. Next, I'm going to create padding horizontally. So we need here px equal to 2. Also, we need little vertical padding using py with the value 1. Then I'm going to make text small using text sm. Also, let's make the font light. Next, I'm going to create some space between the letters using tracking wider. And finally, let's change the color of the text. Let's make it gray using text gray 400. Let's go to the browser. So as you can see, the button is customized. So before we take care of the projects, first I'm going to display all the filter buttons dynamically based on the data we have. This will allow us to easily add, remove, or modify the filter categories in the future without changing our code structure. To do this, we will use the data from our index.js file. Let's go ahead and open this file and then place it on the right side. So again, we will use the data from this file, specifically the array called projects button. I mean this array here. It contains the names of the technologies we want to display as filter buttons. First, let's take a quick look at the data we have in the index.js file for the project section. We have two main exports. The first one is projects data. As for the second one, we have here an array projects button. The first data is an array of project objects. Each object contains information about a project, such as its name, description, image URL, and the technologies used to build it. This data will be used later to display individual projects. Actually, we will take a closer look at this array once we move to the projects part. Right now, our focus is the second array, I mean projects button array. This array is a simple list of strings, each representing a technology category that we want to use for filtering projects. It is essentially a filter menu for our portfolio. Each item in the array is a string that corresponds to a technology or a category. The first item, all, is a catch-all category that, when selected, will show all the projects in the portfolio. Other items like Figma, HTML, CSS, React.js, and so on represent specific technologies. Selecting any of these buttons will filter the displayed projects to only show those that use the chosen technology. So by using an array, we avoid hard-coding buttons directly in the JSX. This makes our code more manageable and flexible. For example, if we want to add a new category, let's say Vue.js, we simply add Vue.js to this array in index.js file. The buttons in the UI will automatically update to include the new category without changing the component code. Now let's bring in the data we just described. I'm going to add here import statement, and then I'm going to import both arrays. I mean projects data and also projects button. We need to import them from assets. Next, let's replace the hard-coded button with a dynamic rendering using the map function. We will use the map method on the projects button array to iterate through each technology and create a button for it. Right now we have the hard-coded button with the text all. We will replace this by mapping through projects button and creating a button element for each item in the array. So here, inside the div elements, I'm going to open curly braces and then insert projects button, followed by the map method. We need here a callback function with two parameters, text and I. So here we are using the map function to loop through every item in the project button array. The text parameter represents the current item in the array, for example, all, Figma, React.js, and so on, and I is the index of the current item. This allows us to access each technology name one by one. Next, we have to insert the button inside the map function. So I'm going to cut this code and paste it here. As you remember from the previous part, whenever you create elements inside a loop, React requires a key prop to uniquely identify each element. We will be using the index I as the key. This helps React efficiently update and render elements without causing performance issues. So I'm going to add here key prop, and as the value I'm going to insert I. Besides that, I'm going to replace this hard-coded text with the actual text. So this replaces our previously hard-coded all text with the actual values from the projects button array. As we loop through the array, the value of text changes and each button displays a different category name. Now if we go to the browser, you will see here all the buttons with different technology names. Okay, so now that we have set up our buttons dynamically using the projects button array, we have made our code much more flexible. If you want to add more categories in the future, you just need to modify the projects button array in the index.js file without touching this components code. This is one of the many advantages of making our UI data-driven. Next, we have to take care of the projects. First of all, we need to style the wrapper developments. I mean this development here, and then we have to add content to our subcomponent project. So let's add here class name, and then we need flex layout, flex, then flex wrap to place the projects on different lines. Also, actually we need here flex wrap, and then we need item center, then justify center. And finally, I'm going to create a gap equal to 5. Next, I'm going to add some content to the project subcomponent. So let's open this file here. And then, instead of this hard-coded text, I'm going to insert an image. I mean the image component. Next, we need to import image components from next image. And actually, we need here quotes. And after that, as you remember, we have to add some attributes to the image component. The first one is source attribute. So in this case, I'm going to display one of the images from projects folder. Let's say the first one. So I'm going to insert here projects folder, and then we need image 1.jpg. Besides that, we need alt attribute. It's going to be project image. Then we need width and height properties. The width is going to be 400. As for the height, I'm going to make it 400 as well. Now, if we go to the browser, we'll find here the image of the project. All right, after that, I'm going to open developments after the image components. Then inside the development, we'll have two elements, h2, heading. Right now, I'm going to insert here some hard-coded data, let's say sparkleglove.com. And then after h2 heading element, I'm going to open p tag with the text description. We will change this hard-coded data soon with the dynamic one. So we need here description. Actually, that's it about the content of the project. Now we have to customize those elements. So let's go ahead and start with the first development. I'm going to add here a class name. First of all, we need to define the width. It's going to be 350 pixels. We need an arbitrary value. As for the smaller breakpoint, I mean SM, we need width to be full, which is 100%. As for the height, I'm going to make it max, max content. Then we need border. The color of the border is going to be, again, yellow, 400. Then we need rounded, LG, in order to make the element rounded. And finally, I'm going to change the cursor. Let's make it pointer. Okay, so as you can see, the element, the wrapper of the project is customized. Next, I'm going to add some styles to the image. So we need here class name. Let's make image rounded using rounded LG. And then I'm going to decrease slightly the opacity. Let's make it 70. All right, after that, I'm going to customize the development, which is placed after image. So we need here class name. First of all, I'm going to define the position of the element. Let's make it absolute. Then we need position relative for the parent element, which is this development here. So let's add here relative. Then I'm going to define top position, which is going to be 0. Then we need width and height, both of them, to be full, 100%. After that, I'm going to use flex layout. So we need flex. Then we have to change the flex direction. Let's make it column. We have to place the flex items vertically in a column. Then I'm going to add here items center and also justify center. Then let's create some gap vertically using gap y2. And also I'm going to change the background color. Let's use BG white. And also I'm going to use opacity. I'm going to make the opacity of white color 95. So we need here slash and 95. Then let's use padding equal to 6. And finally, let's make the element rounded LG. All right, so here we have development. Actually, this development is going to be the backside of our image. Right now, I'm going to customize the heading and the paragraph, and then after that, we will hide this element temporarily. So let's go back to the VS Code and customize H2 heading element. I'm going to add here class name. So we need text LG. Then the font is going to be bold. Also, I'm going to create letter spacing between the letters. So we need tracking white. Actually, we need here dash. And finally, let's change the color of the text. Use text gray 500. So as you can see, the heading is customized. Next, we have paragraph. So let's add to the paragraph class name. I'm going to use text justify. Then we need text gray 500. And finally, I'm going to create little indentation using first letter. Then we need PL padding on the left side equal to 2. All right, so that's it about the backside of our project card. So I'm going to hide it for a while. Let's add here hidden. Actually, not here, but here. We need hidden. So as you can see, the backside is hidden. So once the project is customized, now we have to display all the projects on the page. For that, we have to map through the projects data array and then display every project on the page. Before we do that, I'm going to describe the data in the index.js file in detail. So the projects data array is holding all the data related to each project we want to showcase. Each item in the projects data array is an object representing a single project. Let's go ahead and break down the properties of each project object to understand how they will be used. We have name. This is a string that holds the name of the project. It serves as the project's title, which we will display in the UI. For example, sparklegraph.com or tagtracker.net. It gives viewers a quick idea of what the project is about. Next, we have description. This is a string that provides a brief description of the project. This property will be used to give users more context about what each project entails. For instance, it might describe the website's purpose or the type of content it offers. Next, we have URL. This is the URL path to the project's image. It is a string pointing to the location of an image file, which we use to visually represent the project in the UI. For example, projects/image1jpg. This will help us to dynamically load images using next.js image component. Next, we have tag, which is an array of strings that list the technologies used in the project. It might include items like HTML, CSS, React.js, Next.js, and so on. This property is essential for filtering projects based on selected technologies. The filtering mechanism will check the technology array to determine whether a project should be shown. Now it's time to display all our projects dynamically on the page. Up until now, we only had a placeholder for a single project in the project component, but of course we have multiple projects in our projects data array that we want to showcase. So let's move ahead and make those changes to display them all dynamically using the map method. First, we're going to modify our projects component to loop through each item in the projects data array and render a project component for each one. We'll use the map method for this. So let's go ahead and open projects.jsx file. And here I'm going to insert curly braces followed by projects data. Then we need map method. And I'm going to insert here a callback function with two parameters, data and I. Next, we need to insert here div element, which will wrap the project. So let's open div tag. And then inside the div tag, I'm going to insert projects. As you know, we need here key prop, and the value is going to be, let's open template literal, then we need ID, and I'm going to insert here I. As for the projects, I'm going to add to it two props. The first one is going to be data, and it should be equal to data. And then we need second prop, index, with the value I. So here we're using the map method to loop through each item in the project's data array. For each item, it calls the callback function we have defined, passing the current project data as data and its index as I. Inside the map method, we create a new div for each project. We are using a key prop here to ensure that each div has a unique identifier. In this case, we use a template string to concatenate ID with the current index I. This is important because React uses the key prop to keep track of which items have changed, added, or removed, which helps optimize the rendering process. Inside each div, we render the project component. Here is the cool part. We are now passing the actual project data as props to the project component. We are passing data as a prop called data, which contains all the relevant information for each project, such as its name, description, and image URL. Additionally, we pass the index I to identify the position of the project in the list. This will be useful for animations or other dynamic behaviors. Now, if we go to the browser, you will see here projects, and all of them has the same image. But we will fix that issue in a minute. So now that we are passing data and index as props to the project component, we need to update the project component to use these props. So let's head over to project.jsx file and make here those changes. I'm going to extract data and index props in the project component. So we need here curly braces and then data and index. So here we are using the structuring to extract data and index directly from the props object. This makes it easy to use these values inside our component. Now that we have the data prop, we're going to replace the hard-coded values with the dynamic values passed from the project component. For the image component, we'll replace the src attribute with data.url. So instead of this hard-coded URL, we need data.url. So here, data.url contains the URL of the project's image. By using this dynamic value, the image will change based on the project's data passed through the props. For the project name, we need data.name. This line now dynamically displays the name of each project. It pulls the name property from the data object that was passed as a prop, allowing each project to showcase its specific title. Similarly, we will replace the description. So I'm going to add here data.description. This will now show the actual description of each project based on the desk property in the data object. So if we go to the browser, you will see that all projects have different images. Now if we display those backsides, then you will see that each project card has different title and different description. Okay, so everything works perfectly. Let's get back here. So by making those modifications, we have essentially transformed our project display into a dynamic, data-driven system. Now, whenever we want to add a new project, we just need to update the project's data array in index.js file, and our UI will automatically reflect those changes without modifying any of the JSX in the components. This makes our project section highly flexible and easy to maintain. Let's move on and set up the foundation for our filter navigation. We want to make it so that clicking on the buttons in our project section filters the projects displayed. To achieve this, we're going to create a few state variables and also references. These variables and references will help us keep track of the selected filter, the currently active button, and manage the transitions when changing the filters. So let's dive into it. First, let's define our state variables. I'm going to insert here new state variable. It's going to be tag. Then we need an updater function, set tag. It should be equal to useState. And then I'm going to insert here the default value all. Again, make sure that you import useState from React, otherwise you will get errors. So this line creates a state variable called tag and a function set tag to update its value. We initialize tag with the string all, which will be our default state. This tag state will be used to determine which projects to display based on the selected filter. The initial value all means that by default we want to display all projects. When a user clicks on a filter button, for example React.js, CSS or any other categories, we will update this state with the selected technology. The projects will then be filtered according to the state, displaying only those that match the selected technology. So this state variable essentially controls the filtering logic of our projects. Next, I'm going to create another state variable, and it's going to be index. Then we need set index. It should be equal to useState. And as the default value, I'm going to insert here 0. So this line creates another state variable called index and a function setIndex to update its value. We initialize index with 0. This index state will keep track of which filter button is currently active. For example, when the user clicks on the React.js button, we will update this index state with the index of that button. This is particularly important because we will use this index to apply specific styles or animations to the active button, giving the user a visual indication of which filter is currently selected. It also allows us to smoothly transition between different buttons when the user clicks on a new filter. Next, we need to create a couple of references using the useRef hook. These references will help us manage the previous index and store references to the button elements in the DOM. So I'm going to create new variable. It's going to be prep index, which should be equal to useRef. And as the default value, I'm going to insert here 0. Then we need to import useRef from React. So here we are creating a reference called prep index and initializing it to 0. This reference will keep track of the index of the previously active button. Unlike state variables, references do not trigger a re-render when their values are changed. This is useful because we don't want the component to re-render every time we update this reference. We will use prep index to know which button was previously active, so that we can remove or modify its styles when a new button is clicked. For example, if the current button index is 2 and the previous button index was 1, we can use prep index to find and animate the previous button, removing its highlight or animation. This helps us create a smooth and interactive filter navigation experience. After that, I'm going to create second reference. Let's create a new variable. It's going to be buttons ref, and I'm going to make it equal to useRef with the default value an empty array. So this line creates a reference called buttonsRef and initializes it to an empty array. ButtonsRef will store references to all the filter buttons in our navigation. We will use this array to access the actual button elements in the DOM so that we can apply animations or style changes to specific buttons directly. For instance, when a user clicks on a new filter, we will animate the newly selected button to give it a highlighted effect and remove the effect from the previously active button. By storing references to these buttons, we gain fine control over their styles and animations. This is crucial because some animations or transitions like scaling or changing opacity require direct access to the DOM elements, which isn't possible through state alone. So now that we have created the buttonsRef reference to hold an array of button elements, the next step is to populate this array with the actual button elements as they render. We are going to modify the button element in our map function by adding the ref attribute. So here I'm going to add ref, which will be equal to a callback function. We need elements as the parameter, and then we have to return buttons ref dot current. Then we need push method with the argument element. So here we add a callback function that takes an argument element, which refers to the button element being rendered. This element represents the DOM element of each button. The callback function pushes this element into the buttonsRef.current array. Essentially, it stores the reference to each button in our array. After all buttons are rendered, buttonsRef.current will contain references to every button in the order they were mapped, giving us direct access to them for animation and styling purposes. This is important because later on, when we want to animate the buttons, we will need to directly access these button elements. So by storing these references in buttonsRef, we can achieve that. Now that we have our state variables and references ready, it is time to make our filter navigation work. We'll be implementing a handle-click function to animate the buttons, utilizing useEffect to trigger this animation when a new button is clicked, and filtering the displayed projects based on the selected technology. Additionally, we will ensure that the active filter is applied using the onClick event to set the technology and index states. Let's break this down step by step. Now, the first thing that we need to do is define the handle-click function, which will handle animating the buttons whenever we click on them. So let's go ahead and create a new function here. I'm going to call it handle-click. We need here an arrow function. So we're creating the handle-click function that will apply animations to the button elements using Framer Motion's animate function. The purpose of this function is to provide visual feedback to the user, indicating which button is currently active. It also reverts the previous button to its original style. So as I said, we need animate function. Then we have to import this function from framer motion. As remember, the animate function in framer motion is a powerful tool for creating animations and transitions for DOM elements. It allows you to dynamically change the properties of an element, such as its position, scale, rotation, and opacity, over a specified duration. The way it works is by taking in parameters that define the element to animate, the final state you want to achieve, and any additional options like delay, duration, and easing functions. So here inside animate, I'm going to insert buttons ref dot current. Then we need index number, prep index dot current. Then we need an object with opacity 0.5 and scale 1. So this line accesses the button stored at the previous index in the buttons ref array. It then animates this button to an opacity of 0.5 and scales it back to its original size, scale 1. Essentially, this line reverts the styling of the previously selected button. After that, we need again animate function, and inside the parentheses, I'm going to insert buttons ref dot current. Then we need index, and then opacity 1 and scale 1.2. So this line accesses the button at the current index in the buttons ref array. It animates this button to full opacity and scales it up slightly. This highlights the currently selected button, making it visually distinct. Next, we have to use the useEffect hook to automatically call handle click whenever the index state variable changes. This is necessary to animate the buttons when the user clicks on a different technology filter. So let's use here useEffect hook. I'm going to import it here. So inside the useEffect hook, we need a callback function. Then I'm going to call handle click. And besides that, I'm going to set prep index dot current to index. And finally, we need a dependency array in which I'm going to specify index. So here we are setting up a useEffect hook that runs whenever the index changes. When the user clicks a button, the index state variable changes, indicating a new selection. We use useEffect to trigger handle click, which updates the animations for both the previously selected button and the newly selected button. So we call the handle click function we defined earlier. This animates both the previous and current buttons, providing visual feedback to the user. The next line of code updates prep index.current to store the current index. This is essential because the next time the user clicks a button, the function will know which button was previously selected. As for the dependency array, we ensure that the effect only runs when the index changes, making it an efficient way to manage the animation of the buttons. Next, we have to add an onClick event handler to the button. So I'm going to add here onClick event handler. Then we need a callback function in which we have to update index using setIndex function, and we have to insert here I. So the setIndex function updates the index state to the value of I, which is the index of the button being clicked. This is crucial because we use this index to track which button is currently selected. Also, we will use it to apply animations or styles specific to the selected button using framer motion and update the filter criteria for displaying the project. Next, we have to wrap the button tag with motion in order to apply the framer motion animations to the element. So first of all, I'm going to import motion. And then, as I said, we have to wrap button with motion tag. Besides that, I'm going to add here initial attribute, which should be equal to opacity I equal to 0. This is a conditional statement. We need a ternary operator. Then if this condition is true, we need here 1. And if it is false, we need 0.5. Next, we have scale property. Again, we need here a conditional statement, I equal to 0. If it is true, then we need 1.2. And if it is false, we need 1. So this is an object passed as the initial prop to a motion button element. It defines the initial styles or states for the button when it is first rendered. Here we set two initial styles, opacity and scale. Both of them use a conditional statement. In case of opacity, if I mean the button's index is 0, meaning it is the first button, it sets opacity to 1. It is fully visible. For all other buttons, it sets opacity to 0.5, partially visible. Similar to opacity, the condition in the scale property checks if the button's index is 0. If I is 0, it sets scale to 1.2, slightly larger. For all other buttons, it sets scale to 1, which is normal size. Alright, let's go to the browser and check if everything works fine. So as you can see, once we click the categories, those different buttons, they become active. Okay, so that's it regarding buttons. Now we have to move on to filtering the projects based on the technology selected by the user and displaying them on the page. We have to update the project's data map block in the JSX to include the filtering logic. So as you remember, we have here project's data with map method, and I'm going to insert here the filtering logic. So I'm going to add here filter method, in which I'm going to insert a callback function with project parameter. Then we need to return project.tag.sum, in which I'm going to pass another callback function with the parameter item, and we need here tag equal to all. If this is true, then we need true, and if it is false, then we need item equal to tag. Alright, so let me explain what we are doing here. We are modifying the existing map method on project's data to include a filter that checks which projects should be displayed based on the currently selected technology, tag state. This is how we dynamically update the displayed projects to match the technology filter selected by the user. When a user clicks a technology button, the tag state changes, and this filtering logic determines which projects to show. The filter method in JavaScript is used to create a new array containing elements that meet a specific condition. It loops through each element of the original array, applies the condition defined in a callback function, and includes only those elements for which the condition returns true. This method does not modify the original array. Instead, it generates a new filtered array. The filter method is especially useful when you want to isolate certain data, like filtering a list of items based on a selected category, allowing for more dynamic and interactive content display in applications. Here we are using it to go through each project in the project's data array and return only those projects that match the selected technology category. Essentially, this method lets us control which project should be displayed based on the currently selected technology. Inside the filter method, we then use the sum method on the project.tag array. Let's quickly discuss how the sum method works in JavaScript. This method checks if at least one element in an array satisfies the condition provided in the callback function. If it finds even a single match, it immediately returns true. In our context, this is useful because each project has multiple technologies in its tag array, and we want to check if at least one of those technologies matches the selected filter. Now, let's put this together in our code. The condition we use inside sum is a bit more complex. The condition tag equal to all, and then we have true and item equal to tag. This is a ternary operation. If the currently selected technology, I mean tech, is all, we return true, which means all projects should be included in the new array. If tech is not all, we check if the current item in the project.tech array matches the selected technology. If it does, the sum method returns true, and the filter method includes this project in the array. So to sum up, the filter method creates a new array of projects that pass the condition we have defined. Within this condition, the sum method checks if any of the technologies for a project match the currently selected filter. If the filter is set to all, it includes every project. Otherwise, it filters the projects based on the selected technology. This logic ensures that the displayed projects dynamically change whenever a new filter is selected. Now, we have to add setTech in the onClick event handler. We need setTech, and here I'm going to insert text. So this line is essential because it updates our text state variable with the text of the button that was clicked. Remember, the text state holds the current category we want to filter by, whether it is all, React.js, CSS, or any other technology in our list. By using setTech we are telling React to update the text state with the category of the button the user clicks on. This update triggers a re-render of our component, which then allows our filter logic to kick in and display the projects that match the selected category. Without this line, the text state would remain unchanged and our filter function would not be able to work as intended. In other words, adding setTech makes the filter navigation functional and responsive to the user selection, allowing us to display only the relevant projects on the page. Now, if we go to the browser and select different categories, then you will see that filter navigation works fine. On each click, we're getting here different projects. Now let's add some animations to our projects to make them more visually engaging. To do this, we will wrap the div element containing project component with motion div. So let's go down and wrap these div elements with motion. Next, we need to include the layout property in the motion div. So let's add here layout. The layout prop is a powerful feature of Framer Motion that allows our elements to smoothly transition between different layout states. Essentially, it listens for changes in the position or size of an element and automatically animates those changes, creating a smooth, fluid motion. For our projects, this is especially useful. When we filter the projects by technology, the arrangement of the project cards changes, and adding the layout prop helps animate these changes. Let's go to the browser and check the results. If we click the buttons, then we'll get these nice and cool animations. Alright, so everything works perfectly. Now let's add some scroll triggered animations to our projects to make this section more interactive and appealing. We want these animations to play once we scroll down and the section comes into view. For this, we will use Framer Motion's properties to control how each project appears as it enters the viewport. So let's go to the project.jsx file. So here we will wrap the project's main div with motion. Actually, we need here motion. And then we have to add the following properties to control the animation. So the first one is initial. It's going to be equal to opacity, which will be 0. Then we need y. It should be equal to a conditional statement. We need index modulus 2 equal to 0. Then we need a ternary operator. So with this condition, we have to figure out if the element has an even or an odd index number. So if the condition is true, then we need 100. And if it is false, then we need minus 100. So we got an error here because we have to import motion from Framer Motion. So we no longer have here the error. So this property sets the starting state of the element before the animation begins. So in our case, we have opacity 0, which means that the project will be completely transparent initially. The Y value sets the vertical starting position. If the project's index is even, it will slide in from 100 pixels below. If the index is odd, it will slide in from 100 pixels above. This creates a staggered alternating effect as the projects animate into view. Next we need while in view property, actually attribute, which should be equal to opacity 1 and y 0. So this property defines the animation that should occur once the element comes into the viewport. We set it to opacity 1 and y 0, which means the element will become fully opaque and move to its natural vertical position. This creates a smooth transition from the initial state to the final position as we scroll. Besides that, I'm going to add here a viewport. Then we need here once equal to true. This property configures when the while in view animation should trigger. Here we use once true, which means the animation will only play once when the element first enters the viewport. This is useful for creating a one-time reveal effect as the user scrolls down. And finally, I'm going to add here transition. It should be equal to duration 1. Then we need type. It's going to be spring. And also I'm going to add here stiffness, which will be equal to 100. So this attribute controls how the animation progresses from the initial state to the final state. We set transition to duration 1, type spring, and stiffness 100. The duration 1 means the animation will take 1 second to complete. The type spring creates a spring-like motion, giving the animation a natural bouncy feel. The stiffness 100 parameter controls the stiffness of the spring, affecting how quickly the element comes to rest. A higher stiffness value makes the animation snappier, while a lower value creates a softer, more elastic effect. So let's go to the browser, reload the page, and scroll down. Once we reach the project section, then we will get this nice and cool effect. All right. So now it's time to take care of the backsides of the project cards, which at this moment are hidden. The first thing that we need to do is remove the hidden class from the backside of the cards. This change will make sure the backsides are not permanently hidden and can be toggled on and off using state. So next we need to create a state variable to manage the visibility of the card's backside. Let's do that with this line of code. I mean, we have to add here state variable show with the setShow updated function. Then we need useState, and as the default value, I'm going to insert here false. Actually, we need here false. So here we are using the useState hook to create a state variable named show, initializing it to false. The show variable will determine whether the backside of the card is visible. The setShow function is used to update this variable's value. In this context, when show is true, it means the backside of the card is visible, and when it is false, it means the backside is hidden. Now to handle toggling the backside's visibility, we add an onClick event handler to the card. So we will use the following code. I'm going to add here onClick event handler, and then we need a callback function in which we have to return setShow with another callback function with the parameter show, and then we have to return notShow. So this code will execute whenever the card is clicked. The setShow function here takes the current value of show and toggles it. The part inside the callback function uses an arrow function to flip the current value. If show is true, it changes to false, and vice versa. This makes the card's backside appear when clicked and disappear when clicked again. After that, we need to wrap the backside's div with the motion div to enable animations. So here I'm going to add motion, This allows us to control the opacity of the backside when it is shown or hidden. We use two properties on motion div. The first one is initial. It should be equal to opacity 0. It sets the initial opacity of the backside to 0 when the card is first rendered, making it invisible. And then we need animate with the value opacity. Then we need show with a ternary operator. If the show is true, then we need 1, and if it is false, then we need 0. So the animate attribute controls the animation whenever the show state changes. If show is true, the opacity will animate to 1, making the backside fully visible. If show is false, it will animate to 0, making the backside invisible again. These changes give us a smooth and interactive way to toggle the backside of the project cards, making the user experience more dynamic and engaging. Now, if we go to the browser and click the projects, then we will get here backsides with nice and cool fade effect. So everything works fine. We can filter the projects by the categories. Also, we can display the backsides of the projects. And if we reload the page and scroll down, we will get this nice and cool animation. Alright, so we reached the end of this part. In this section, we tackled the projects component and added a whole new level of interactivity. We started by displaying all our project cards dynamically, filtering them based on technology with smooth animations. We also added a cool reveal effect for the backsides of the cards, allowing users to interact with each project and see its description in a stylish way. If you enjoyed this part and found it helpful, don't forget to hit the like button, subscribe to the channel, and tap the bell icon so you won't miss any future updates. Also, drop a comment below if you have any questions or thoughts about this section. I'd love to hear from you. In the next part, we're going to dive into building the pricing and content sections. We will add even more functionality and styling to make our website truly stand out. So stay tuned and I'll see you in the next video.